Okay, here's the situation. You've got an FDM style 3D printer, similar to this heavily modified Ender 3 Pro that I have sitting here. And you've been using it to great success to make all kinds of things, but the resolution bothers you. It probably came with a 0.4 millimeter nozzle. I guess you could put a smaller nozzle on there, but then you gotta modify the firmware, and it's always gonna have those layer lines no matter what you do, and they're weaker on the Z direction, so they're easy to break. And so, you know, FDM 3D printing has its limitations. And you've been seeing all of these videos and all of the posts and online forums about resin-based 3D printing. And you know, it's an entirely different paradigm from the bead of molten plastic, which is FDM style printing. So I have used resin-based printers before. I used 2 different Formlabs machines in the course of my professional activities. The Formlabs machines, perfect as they are, cost $5,000. So they are not really within the grasp and the reach of just the regular DIYer like you and me. So lately, we've got a bunch of inexpensive resin-based printers that are hitting the market, and this is one of them, and it looks like it's going to be a good one. This is the Elegoo Mars 3D printer, and I'm assuming the goo is reference to the photopolymer UV curing resin here. So very gooey stuff. Not nearly as clean as the FDM, thermoplastic material that gets squeezed out of there. So this is going to be quite an involved process, but the benefit to this style of printer is it comes fully assembled. So there's no kit involved here. I'm just going to pull the unit out of this box and start printing with it. But because I have never done this before, like I said, I used those Formlabs machines, but they were already set up. All I had to do was kind of get into the Formlabs slicer. I think it's still called a slicer, just to get into their slicer program and send the prints. So this is going to be my first time setting up and using one of these home-based printers for UV curing resin. So come along with me on the journey, and you can learn basically what it'll be like for you if you get one of these. And I should be able to answer the question that you all have, and that is resin printing better than FDM printing? So let's figure that out. Roll the intro and we'll get into it. I've got to give the usual boring disclaimer that, of course, this printer was given to me for free by Elegoo, who want me to show you their printer. I didn't buy the printer. That doesn't mean that I have to say nice things about it. So I'm going to tell you exactly what I think of this printer as I experience it. Well, I mean, I won't have to tell you. You guys are going to be coming along with me on the journey while I figure this thing out. First of all, it seems to be packaged pretty good. There we go. Okay, so there's that. And yeah, like I said, we got an instruction manual, and then the entire printer is just one solid unit here. You can see it in the box. So pulling that out. Yep. Okay. Hopefully there wasn't anything else in that box that I need. Now, interesting note, this acrylic is tinted orange for a reason, and that is to block the ultraviolet laser from hitting your eyes. So it's a safety mechanism. You can still look in and see the print happening, but that way, we get to keep our vision. I like my vision. I don't want to lose it, so I'm glad that is part of the design. Of course, not invented by Elegoo or anything like that. Probably the usual case here where almost all of this is, if not a direct knockoff, then darn close to a knockoff of a Western design. And so far, this looks really clean. We've got a single Z axis that holds the platen, and the platen here will sit down there against the base of the this is the pool that holds all of the resin. And so the platen will sit right up against the glass at first, and then the platen lifts a little bit, next layer, next layer, next layer. And it's a pretty simple process. It's not nearly as many moving components as you have in an FDM style printer with all the X, Y, and Z all having to move, also needing an extruder. So none of those are needed. And instead, all that complication is replaced by the process of UV curing the resin. Well, that's interesting. Didn't quite get all the plastic off of there. That'll be okay. It was kind of stuck. The screen was screwed with that film protection there, so it's stuck in the gap. But yeah, that's a nice clean unit there. And there's the lid. Put the seam towards the back, and that's going to be my printer. How clean is that? Really cool. So also sent to me by Elegoo is this photopolymer resin. This is green, kind of the design prototype test color these days. And yeah, so that is photopolymer resin, storage condition, avoid direct sunlight, keep indoors and sealed. So yeah, I will probably keep it in this box because it does cure with ultraviolet, and my studio lights probably have a bit of ultraviolet as well as, you know, outdoor sunshine, so best to keep this thing in the dark even though it also is in a dark container. But let's look at what's in the box here. Of course, we have a power plug. There's the power supply. Again, look at that little dinky power supply. These don't take nearly they're not nearly the power hogs that FDM printers are, because there's hardly anything moving. I mean, I don't know how the guts of this thing work. Maybe I will take it apart. In fact, you know what? I'm gonna take this thing apart and look at it with all of you to figure out how it works. But some of these have what's called a MEMS unit, MEMS. So it's basically they shine a laser on a mirror, and the mirror is just constantly moving in all the directions, and it can move the laser very quickly, which allows you to get fast print speeds. And of course, fast print speeds are better. Got a USB drive there in the case. We got some gloves. I also had these gloves. These are like your Subway sandwich making gloves, I guess. These came with the resin. So lots of ways to keep the resin off your hands. I might put a drop cloth down on this table, although I don't think I'm gonna be that messy. But yeah, you definitely wanna keep the resin off of things. And look at this, how cool is this, you guys? We've got filter cones, paper filter cones. So see if I can pull one of these out of here. They're kind of stuck together. Come on out of there, there we go. So you can see there's a little filter right there at the base of the cone, and so we'll be able to filter our resin through as we're putting it into the cup there. We got to get a nice clean, I don't know what you call it. I should look up the terminology here, but the reservoir, you got to get a nice clean reservoir. We've got some masks because this stuff is stinky, and finally we've got the scraper. And this is going to be needed when you're cleaning up. When it's all said and done, you'll have to scrape it off. So unlike FDM printers, where you can print, and especially if you're printing in PLA, you just leave the roll of film right on the printer. Just leave the printer for months if you want. There's not going to be any harm in that. With one of these, you've got to set it up, you've got to pour all the resin in, and when you're done, you want to clean that. You got to get it fully clean before you put it away. Unless you're just going to be constantly printing with it, and even then, you know, you're going to have to do maintenance cycles because you don't want that resin to build up on the glass of the reservoir. Finally, in the box, we have a couple of tools. I don't know when those are going to be needed, and the obligatory flush cutters that come in every one of these 3D printer kits. Yeah, that's all there is to it. How simple is that? So the complication will come when we are actually getting this printing and dealing with the resin. But let's take a look at the instruction manual and figure out exactly what it is that I need to do. I need to download a slicer software, I'm sure, and pour the resin in the tray, and yeah. All right, to the computer. Here on the World Wide Web, we are looking at the website for Chitubox, and Chitubox is the slicing software that's recommended in the user manual for this printer. Beyond that, though, Uncle Jesse, shout out to the other YouTuber, Uncle Jesse, he says it's the best one out there right now as of, you know, what, June 30th, 2019. There's nothing better. So yeah, let's get Chitubox, right? Well, there's a couple of red flags here. First of all, they really want cookies to be used. Look at this pop-up here on the bottom. I've never seen it quite like this before. And when you click on the account tab here, you can see English and Chinese. So that's pretty much the tell that Chi2Box is a Chinese company. And, you know, I'm a little bit skeptical, a little bit hesitant about Chinese companies. Thinking back to the last Chinese New Year, where so many Chinese citizens were not allowed to get on airplanes because their social credit score wasn't high enough to allow them to fly. So we all know that China, the Chinese Communist Party, has designs on global control, and I can easily see a situation in the future where they're tracking me on cookies and all that, and they decide that my social credit isn't high enough to, I don't know, purchase the latest and greatest product from China or something like that. You know, they're going to keep global citizens in line, not just their own citizens. So I really don't trust Chinese companies. You know, I don't trust most companies, but Chinese companies are especially not trustworthy because they are just one step removed from the Chinese Communist Party. So maybe I don't have to use cookies. I can just press the download button and get the latest and greatest Chi2Box software. Here's the Windows 64 version, download. But no, it just boots you back into the account login page. And I already tried using a bogus email. That doesn't work. They really want to know who you actually are so they can track you. Luckily, the Chi2Box software comes on the thumb drive with the printer here. So I do have a version of Chi2Box to install. Of course, if you're really being paranoid, I just stuck an unknown USB drive from China into my computer. So I probably have all of the Chinese viruses at this point. Anyway, here is the geometry that I'm going to print, and I'm going to use this as my test geometry for a couple of reasons. First of all, it's a really challenging print, right? This would be a nightmare to print with an FDM printer because there's absolutely not a single flat surface anywhere on this print. So that means you're going to need 100% support material to get it to work. Now, you can see these sort of creases here, like there's one on the outside. That's the parting line for the two-part mold. So I was contracted to build this part for an industrial process. That's injection molding, and they're going to produce tons of them. So this is not just something that you made to be 3D printed. This is prototyping. And as it's a prototype, we need it to be as true to the final injection molded part as we can possibly get it, which means nobody who's even halfway professional would even think of using FDM printers to make this part. So this is the ideal part to make on a resin-based printer. All right, so this is Chi2Box fully installed, and you can see that I've imported my model here, and I've even drawn in the supports or auto-generated the supports. And this is not a review for Chi2Box, which is an entirely different thing from this printer, but you absolutely need a good slicer to get the printer to work to its full potential. So this does seem to be a good slicer. Unfortunately, it seems really similar to the Formlabs slicer that I was using with that consulting job. And well, you guys know how I feel about copycats. So Formlabs, very much an entrepreneurial venture by some guys here from America, from the West, and it's just another instance of China coming in and copying the hard work done by an entrepreneurial team here in the West. So it sucks. It sucks. As an entrepreneur, I really empathize with these guys getting their products stolen. So I don't know if this is a stolen product or not. It seems kind of similar. But anyway, this is ready to go. So let's just hit this slice button here. And now we can see here on the right is this whatever bar that you can use to just see each layer. So there's layer 1, 2, 3. You can just see the cross section here in the black, and that's the cross section of what it's printing. And then on the left hand side there, you can see the actual part being printed. So pretty cool little simulation. So I'll just save this file to the USB drive and stick the USB drive into the printer, and we should be able to print it. As I was installing all that stuff onto the computer, I read the manual and I learned a couple of key bits of information. First of all, you do not use this scraper to scrape the bottom reservoir, the glass down there. See, it says don't scrape there. It's only used for scraping the platen. And that also is something interesting that I learned, because this platen looks like a familiar size, right? That's about the size of your cell phone, and there's a reason for that. This is not a laser-based SLA printer. This is an LED printer. So that inside there is basically just a cell phone screen behind some glass. So that's why you're not going to scrape that glass. You'll introduce scratches or whatever that will affect your print quality. So you want to treat that glass right there as nicely as you can. And the scraper here is for scraping parts off the platen. Also here on the very last page of the manual, I learned that these filters are not for pouring resin into the reservoir from the bottle. They're not for that. They're for quite the opposite. They're for taking the reservoir, once you've finished with the print, and pouring the resin back into the bottle. And that way, any printy bits or other contaminants don't get put back in the bottle once you're done printing. So, couple of key little bits of information, just thought I'd share. So I followed the instructions here for leveling the platen, and I've also got the USB drive installed here into the back of the printer. So I'm ready to go. Let's add this green resin into the reservoir, and it says to fill it up about 1/3 of the way. This is a pretty small print, so I don't know that I need that much resin in there, but just in case. All right, looks good to me. And then down here, there's the print menu, and then you can actually see your print. It's got a little picture of it, pops it up so you know that the print is the one that you want, and then just press play. Put this lid on there. I'm going to sleep, so I will catch up with you guys and this print first thing in the morning, and we can figure out how the whole thing's worked out. The inaugural print is done, but there's a problem. Let's take a look at this up close, and we will see that for some reason my print got stretched. So that arm to that arm should be 90 degrees, and it got stretched in the Z direction for some reason. So I'm going to wash this right here with this alcohol in that little tub, and then we'll take it outside and cure it in the sunlight, and then maybe try to figure out why it's doing this. Before I finish curing this in the sunlight, let's run the test print that came on the machine. And the reason I want to do that is to tell if I did something wrong setting up the slicer. I mean, I went through the slicer and I can't see that I did anything wrong. But if the test print comes out fine, then we know it's something I did. You can see the first layer that's printing. These first few layers, it takes longer to do them because it's really trying to bond the part to the platen. All right, well, now that that's printing, let's get this part cleaned up. The part here is kind of sticky, gooey, slimy to the touch, and we need to just wash off that outer skin of resin, basically. Just get that sort of the drippings off. So just rinse it in a bath of alcohol, like so. And then we'll just pull it out and let it sit in the sun, and all that resin will fully cure that hasn't cured already. So that's the one final step that's sort of necessary in these resin printers, unfortunately. They don't just pop off the bed ready to go. Okay, we're 85% of the way through this print here. This is the sample print that came on the machine, and this is very important. This is very telling about these machines coming from China, because this is really no different than all the other models that you're getting from all the other Chinese companies. And what's happening is you can see that the platen lifts up above the next layer height, and that gives a moment for the resin to flow in and fill in the gaps, and then it sinks back down to the correct layer height. It hits it with the ultraviolet light, and that's the layer. That's how fast the layer gets made. But pay attention to each time that it lifts. You hear that thunk? And also, did you see the ripple in the pool of resin? What's happening is the part, and you can see the shape of the part here. So the circle and the little, that is suction cupping. It's basically getting almost glued down to the glass on the bottom of the reservoir. So that's a problem, and in order to overcome that problem, the fancy, more expensive resin printers have a flexible transparent membrane, and they peel. So instead of coming straight up off the bed like that, they peel, and it's just like having a flexible bed on your FDM printer. You pay for what you get, I guess. This still produces prints. It's pretty incredible what it's doing for, what, $350, but it's far from perfect, that's for sure. All right, so the double rook print that came on the SD card from the factory, that's completed. Let's turn off the printer so we're not talking over that fan noise anymore. And now let's just take a closer look at this print. Now you can see it as it's sitting right there. There's like little drip. So that's why we have to rinse the parts in alcohol to get all of that off. And then we stick it in the sun, or you can make a DIY ultraviolet curing chamber, but you have to do that final process just to get it fully cured. So the part will be fully done at that point. That wasn't too bad. All right, let's go stick those in the sunshine and get them cured. Well, this is interesting. You can see the air bubbles here in the base of these parts, and I don't know if those air bubbles are caused by the alcohol getting in there, but I don't think that's the case. I think that's uncured resin inside of an internal cavity without a drainage hole. Yeah, see if that hardens after leaving it in the sun for an hour or so. We'll see what happens. Actually, I don't even need to wait an hour because this is extremely hot to the touch, which means that the ultraviolet light from the sun is causing the chemical reaction to take place in there, and the exothermic reaction is creating heat. All right, these came out looking just fine. There's no weird proportionality to them, unlike this one that's all stretched. So that means that I did something wrong when I was setting this up in the slicer. Well, I think I found the reason that I got such a funky print here on this part. Here in settings, and then you got to click on default. No, you got to click on this. So it's a little bit hidden. And then you can choose, where's our printer here? The Elegoo Mars. Okay. And now that we've done that, we can close this down and reslice this and send that newly sliced geometry, and we should get a perfectly viable print. All right, let's empty that resin tray back into the bottle. So what I want to do here is switch colors, and the first thing that I need to do, of course, is to clean the current tray. So here we have the bottle. Get it ready, and that looks like it doesn't quite. So you see there's actually a little bit of, you can see my finger. Here's a Harbor Freight funnel, so I'm just going to use that to get it the rest of the way. It's funny, now that I'm emptying this, I'm feeling this membrane. It's kind of like a drum. It's interesting. So I guess I just have to hold it here while it drains for a few minutes. Okay, I'm just going to prop it there like that and let all of the resin drain off of the film, and then I will fill up the reservoir again with the new color. Well, this is interesting. You can see I'm wiping it gently with this paper towel and some rubbing alcohol just to fully clean it. And I'm hoping this shows up on camera, but basically there's a little outline of beads where those two circles are, and those circles are where the rook's printed. So clearly the repetitive printing in one spot sort of wears out the film. It does something to the film. So I don't know how long this film is going to last, because that's only a single print and it's already showing up on the film here. So, you know, just interesting. You can obviously replace that film, but I wonder how much that costs. Here's the photopolymer resin that was sent to me by Elegoo, and you can see what the bottle looks like, and you can see that there's a label on it. Now, opening up this box here, this is the stuff that I ordered because I wanted the second color, and this wrapping, this packaging is exactly the same, and this bottle is exactly the same. It's just got a different label on it. So that makes me think that this resin is being produced in the same factory for the two different brands. So we should get no difference in results if that's the case, but it also sort of hints at the larger thing that I think, and that is these printers are a commodity. Let's put this resin in there now and use this different color. All right. That should be about enough. A little bit more. Sending a print to this is incredibly simple. Not nearly as much hassle as setting up an FDM print, but it's all the cleanup that makes it a hassle.
5 hours later.
And here it is after it's been rinsed and dried in the alcohol. So let's just clip off all the little supports here. In fact, we might not even need the clippers. We should just be able to break them off. Yep, just a little push. Now it's worth noting that here at the top where the part first started to print, so everything else was support material and then it starts with the part, I had to add these extra little supports. And that's because the island was breaking off from that single support. And yeah, that was a problem. But even with these extra supports, it still wasn't enough. I should have added supports all the way down there. You can see the little bit of, well, you see that line? And that's because the part was flexing as it was printing, as it was being pulled up off that bed. So yeah, there's an art form to the support material here on these parts. So there's the part, but today is a real cloudy day, so I can't take this out into the sunshine to finish curing it, and I don't have a curing station built yet. So in the meantime, I'm going to do this little hack here where I'm going to use the auto exposure, or I don't know what this is, but it's just sort of like a self-test exposure. Yeah, you guys can see that purple ring. I can just sort of like rotate this part around that, and it should finish curing. And I can feel it. I wish you guys could feel this with me, but the part becomes sort of less gummy. The surface becomes more hard. The hazards of being a YouTuber. I just pinched the holy bejesus out of my hand with my tripod. It hurts. Anyway, let's talk about these prints, shall we? Okay, so starting off with the very first print, the one with the bad, what is it, the bad slicer. So not only did I get the slicer wrong, but I also didn't wait a long enough time for this to clean in the alcohol solution. And what you can see here is down in that corner where my thumbnail is, that should be a nice sharp corner. Like look at the corner up here, nice and sharp. And basically that's just sort of extra resin drippings that I took out into the sun and they cured. So that'll mess your print up pretty nicely. So you definitely need to clean your prints sufficiently before you do the final curing of your part. So this was one of the two torture tests, did these things side by side. And this is the print that comes with the printer. And yeah, it's perfect. You'd expect it to be. The Elegoo Mars makes amazing prints. The lesson to learn here is the white powder. So what is that? That is because I did not let the alcohol that I rinsed it with fully dry before I stuck it in the sun. So if you still have alcohol on it and you do the finished curing in the sun or in your curing station, that's what you're going to get, some white residue. The next print I tried to do was the fixed slicer, and it was proceeding perfectly. This looks fantastic. You can see there's an iffy moment here at the top where that single support fang is holding the tip of the print. So basically the print was printing from there all the way till it reached that fang over there. So basically printed that deep before it had two pieces of support on it. And so I'm incredibly impressed that it made it this far, because we saw with the rook pieces where it was popping up off the bed and actually vibrating the bed as it did that. So the fact that this part was able to sort of violently pop up off the bed like that and not break off, well, that's impressive. But anyway, what happened here, you can see it's an incomplete part, and my 2-year-old walked into the room and unplugged the printer. I guess he wanted my attention. And for the first time ever, I've wished that a printer had print resume on power loss. Unfortunately, this one doesn't. So if the power cuts out mid-print, you will have an incomplete print and you'll need to start over. And that's exactly what I did here using the black resin. The problem here you can see is that single support did not do its job holding the tip there. So it's pretty interesting. It held it for a little while and then it just sat there, it broke off the support and it just sat in the bed for that whole print until the support here and the support here caught up to it. And then they picked it up and you can see that happen. So yeah, support materials on these prints does seem to be a bit of an art form. You don't want too many attachment points because the attachment points do show in the final product, but you need enough so that it doesn't break off. And just to show you guys again, close up here, you can see those 4 extra little support bits that I had to make here on this part. So finally, here's my successful print. Now, I needed a little bit more than just those 4 supports. You can see the little bit of artifacting here. It's not quite perfect. See the little ridge? So if I had more support, I could have gotten this to be absolutely perfect, but I am super impressed. You can see some of the voxels, the voxel lines, just some striations in the print, but they're not noticeable that much. You know, you could easily sort of sand them out if you really wanted to. Really, just super impressive stuff out of a $250 printer. Just phenomenal. Now there's a reason that I chose this as the geometry, as my chest geometry, and that is because I have this part left over from when I was doing that contracting job, and this was printed on a Form 2. Actually, it might have been a Form 1. I think it was a Form 2. So we're now up to Form 3 at Formlabs, and you know they've got the peeling bed and all that other fancy stuff. So that's a $3,000 printer, or $4,000 printer, the Form 3. $5,000 once you get the curing station and all of that, but the prints are what, 5-10% better than what I'm getting out of a $250 printer. So $250, $4,000. That's quite the price difference for that extra 10%. Then that's just how it goes. The last 10% takes all the time and costs all the money. So this is definitely better. And if you are a professional, you're definitely going to want to go with the Form printers, but the Formlabs printers. But man, for the rest of us, this is so close. It's just super impressive. $250 for this printer to make parts like this. Yeah, I'm surprised. This is not the level of quality I was expecting out of this printer. This is definitely better than I thought. So here's the part fully removed, and it's not cured. Like, I did not stick this in the sun, so it's not fully hardened, but I can still sort of use it to demonstrate the strength characteristics of resin. So you can see this uncured part will bend to a point, and then it's just going to snap there. Oh, that one's really bending. So like I said, uncured part here, which is part of the reason why it's so flexible. But these cured parts will, there we go, they will bend, they will break. Let's just take this part here and do the same thing. Wow, actually pretty strong. Not too bad, there we go. They do snap in the end, but they have quite a bit to go before they do snap. Let's try it again with this part here. This has not been cured. Yep, that's a good little snap. So yeah, you can see they do break, but they are pretty strong, reasonably strong. The benefit to the resin is that it's equally strong in all directions, X, Y, and Z. So I don't know, you might actually have some functional prints that you can make out of this stuff. It doesn't just have to be decorative. As promised, here's the thing disassembled, at least a little bit. Okay, so what we've got going on here is this ribbon cable coming off the control board here is going to the cell phone screen, which is right up against the glass. So right behind there is the cell phone screen. And then what you have is an ultraviolet light, a very powerful ultraviolet light that requires this heatsink and a fan to keep it cool. And that's basically projecting light through the cell phone screen, so that's a transparent LED screen. And so that's the light that cures the resin, and then the screen either blocks the light pixel by pixel or it lets the light through pixel by pixel. So I don't know what this control board is. Obviously it's not something that we've seen before because it would be entirely different than your regular Cartesian style FDM printer. So this is basically probably a very simplified cell phone control board. You know, they don't have to get it into the small spaces that a cell phone would have to be, but it's probably got chips that you're going to find out of cell phones, and yeah, it's going to be just a dumbed down cell phone basically. Well, just the screen. We don't need all the other functionality, all the radios and whatnot from a cell phone. So that's probably a pretty basic control board. And then we have the secondary screen, and that's the touch screen here on the front, and that's also obviously controlled by the control board. So there might be two different chips, each running their own screen here on the control board. And then taking a look here at the back, we can see the control board with the typical hot snot glue to just keep things plugged in. There's a little buck converter. That's a boost controller, so that gets you from, I don't know, 12 volts or something up to like whatever the voltage is needed on the on that high-powered UV light. And that's pretty much all there is to it. So almost all of this technology is just takeoffs from the cell phone industry, and it has very little to do with 3D printing. There's our single stepper motor that drives the lead screw here. So that's our only moving component. And then of course, you're gonna have this linear rail right there that controls the motion. So the lead screw here gets the head to the right height, and the thing that keeps that rigid from moving is the linear motion guide there. The final question left to answer is resin-based 3D printing better than FDM 3D printing? Like, if you're a newbie and you have to choose between one or the other of these machines, which one should you get? So it's a good question, but before I answer it, let's talk about these wonderful guys. These are my monetary supporters for this channel, and without them, the truth is I would not be making videos. It's a small channel, and I absolutely rely on their support. So thank you so much if you are one of these guys, and if you're not one of these guys, maybe consider joining their ranks. All right, so resin printing clearly makes more detailed parts than an FDM machine. Now, like I said in the beginning, you could put a 0.2 millimeter nozzle on this machine, and you could probably, with a lot of effort, get a very finely detailed print off of an FDM machine. A few years ago, there were a lot of people trying it, and you don't see a lot of people doing it anymore because it's just too much effort, and it's just not worth it. So if you need detailed prints, resin printing is the way to go. And it's surprisingly strong. I thought it would be weaker, the prints would be weaker than they are. So yeah, pretty good strength, really good detail. If that's what you're after, detail plus a little bit of strength, you can certainly make some functional prints out of this. And if you're making decorative prints, this is definitely the way to go. But you are limited to a single material. And that material is a very photosensitive UV curing resin. And it has to be more photosensitive than the stuff that they're using in SLA machines, because the laser, the ultraviolet laser, is more powerful. So you need less of the catalyst. So probably that means that the SLA prints are going to be stronger. But I don't know, I'm not a chemist. So there are, of course, nuances, but basically you're making the decision based on resolution. That's why you want a resin-based machine. For the ability to print with thermoplastics, a wide range of different things, even like, rubbery, supporting, support material, rubbery material, all kinds of different stuff. This is just going to be much more versatile, but you're going to lose the resolution, and you're also going to lose strength in the Z direction. So the resin, equally strong X, Y, and Z. All directions, this is equally strong. With FDM printing, those stacked layers, the prints tend to break. So even if you are making functional prints, I'm gonna say that the Z direction on an FDM printer is weaker than any direction with the resin printers. Now that's just based on my little finger calibration test that you saw me, the brake test you saw me do. I'm really looking forward to Stefan at CNC Kitchen doing a comparison video. Of course, that's probably gonna come eventually. He'll do a Prusa, the Prusa printer. He'll compare that to the Prusa FDM printer and the strength of the parts. So I imagine that's something he's working on with his testing apparatus. But in the meantime, I can tell you just off the cuff that they're about the same or maybe a little bit weaker with the FDM prints in the Z direction. But X and Y, a lot stronger here, especially if you're going to use something like carbon fiber impregnated PETG. That's going to be a very high performance material. So there are ways to engineer your parts from an FDM machine that are completely viable, whereas if you're using them for mechanical purposes, the resin prints are not going to do it. So yeah, it's better. Resin printing is better in a way. It's easier to use. You basically just pour the resin in. The slicer software takes like no time. You don't have to get somebody's custom slicing profile to get it to work. It's so easy. With that Chi2 box slicer, which, you know, dubious as it might be, functions fantastically. And it's just super easy. Put your geometry in there, press slice, make sure you've got your supports where you need them, and it'll print. And then you just have to clean up the resin after you're done. So much easier, much higher resolution for the introductory person to 3D printing. I think this is going to be a winner. But if you really want to get into it and you want to tinker and you want to make some truly functional, mechanically speaking, some truly functional parts, then FDM 3D printing is still where it's at. And that's obviously still where I'm going to be spending the bulk of my time on this channel. All right, well, that's about it for this video. Thanks for watching. See you next time.